This is a continuation of our discussion from section 1.1 in MA300 statistics. In this section, chapter 1, section 2, we talk about simple random sampling. In section 1.1, we talked about the kind of studies that could be performed, but then we might ask the question, if we're describing data, or if we are looking to perform an experiment, if we're reaching inferences, we have to find a fair way of representing that population. Most often in statistics, the most fair way of representing a population is to understand what we call simple random sampling. That is a method for finding subjects or data points within our population that allow every element in that population to have an equal opportunity of being chosen for the study. So simple random sampling is defined as follows. In simple random sampling, it's a procedure in which each possible sample is given a size of a given size is equally likely to be the one obtained. A simple random sample is a sample obtained by simple random sampling. Now really there are two types of simple random sampling. One is a simple random sampling with replacement, whereby a member of the population can be selected more than once. When we think about this, for example, if random numbers are being chosen for a contest, for example, it is possible that out of those numbers, one of those numbers could be chosen more than once unless we take that number off of our list of possible winning numbers. On the other hand, a simple random sampling without replacement, we just refer to that as SRS, is the most common one, whereby a member of the population can only be selected at most once. One method of simple random sampling would be obtaining a simple random number picked by slips out of paper in a box, right? Somebody reaches into the box and pulls out a slip. Now, of course, this is impractical when the population is large, but there are procedures that are very close to using this type of procedure for a large population. One involves a table of random numbers. A table of randomly chosen digits is illustrated in the picture right here. This is a random number table. Actually, it's table 1.1 in your textbook. The way we read it is that we could choose numbers from a column. Let me get my little pointer here. We can choose a line number from a column here on the left. We choose a column number on the right, and as we go by these rows here on the left, we could just start going down one randomly and pick numbers. So how should we do it? Let's say we were asked to find a set of 20 random 3-digit numbers. Well, one method would be essentially to find a random place to start somewhere in the table and then start selecting those numbers one by one until we had a list of 20. In this one example, I've got an example where we start off right here. We started out in row 3 in column 30 through 39. And because we want 3-digit numbers, we are starting out right here with the number 069. And as we work our way down the column, this is what we would typically do. Start choosing these numbers one by one as we go down the column. So for example, you see 759 in our set. We go down, we see 009 in our set. And as we go down to the bottom, let's say we run out of enough digits right here, 178, that's in the set, but then we start going up to the next row. So kind of like a J sign, right? We would stop at 178 and then come up here and we see 84 and then across that little empty space 9. Well, that's our next number, 849. And there's two more digits right here, 578 and 404, all on our list of 20 random numbers. And that's how we might actually go through and pick a simple random sample of these numbers. Now, usually we don't resort to tables if we don't need to. We do have statistical software, and in fact, we are on our discussion board going to be using Excel as our graphing random number generator, and I'll show you how that's done in the seminar. But to obtain a simple random sample, we can use a random number generator, and this random number generator provides samples with replacement or without replacement. We do want to be aware of which one is being done whenever we choose this. When we use our random number generator in Excel and we just enter in the command RND, which I'll talk about, you get a simple random sample number with replacement. So that number could potentially be chosen twice in any set of randomly chosen numbers. But let's talk about an example right here. Let's say that there are members of a population are numbered 1 through 5. The question here is, let's list 10 possible samples without replacement of size 3 from the population. And let's answer these questions. If a simple random sample of size 3 is taken from the population, what are the chances of selecting 1, 3, and 5 as your sample? And let's explain the answer right here. And then finally, let's use the Table 1 in Appendix A to obtain a simple random sample of size 3 from the population, and start with a single digit in number in line number 5, and on column 20. So line number 5, column 20. I'll go ahead and explain what that is right now here before we even start our question. We'll come back to this. Let me go back to my number generator right here. Line number 5 is right here. And it says start with line number 5, column 20. And we're going to go over here to column 20. And we see that right away the very first digit number that we can choose is 5. So let's see how this is going to work out right here. We're asked to list the possible 10 number samples here. So our possible samples, choosing from the population 1, 2, 3, 4, and 5, are 1, 2, and 3, 1, 2, and 4, 1, 2, and 5, 1, 3, and 4, 1, 3, and 5, 1, 4, and 5, 2, 3, and 4, 2, 3, and 5, 2, 4, and 5, and then finally 3, 4, and 5. There are 10 possible ways to pick 3 of these 5 numbers at a time. That being the case, if we were told, let's figure out what it would be for us to pick the samples 1, 3, and 5, well, we see there's one way to pick the numbers 1, 3, and 5 as our sample out of a total of 10 samples. So we're going to say that there's a 1 in 10 chance, or 1/10 probability, which we'll describe in Chapter 5, of actually obtaining that particular combination. So it says pick 3 random numbers from our table starting in line 5, going by 20, right? Starting column 5, line 20. And I picked 5, 9, and 6. If we go back to our table, we see that if we are at line 5, and we go over to column 20, we see 5 as the first number, 9, and then 6 as the next number after that. So that's 3 random numbers from our generator starting at line 5, column 20. So if we're looking for that, let's say that I had numbered my samples by counting 1, 2, 3, 4, 5, and go on down the list. So I'd have 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10 samples. I see that randomly choosing 5, I would have gone 1, 2, 3, 4. Here's number 5, so I randomly picked the set 1, 3, and 5 from the way that I had it numbered. Number 9 was 2, 4, and 5, and number 6 was 1, 4, and 5. So I picked samples 1 through 5, 1, 4, 5, and 2, 4, 5 just randomly from our table. That's the idea of simple random sampling. We're just trying to go through and find a way to generate a way to pick numbers at random. Let's try another one here just as an exercise. Let's see. Let's list the top 5 Oklahoma state officials are displayed in section table 1, 2 right here. So here we are. Use that table to solve the following problems. And A says, let's list the possible sample sizes of 1 that can be obtained from a population of these 5 officials. In B, we'll ask, what is the difference between obtaining a simple random sample of size 1 and selecting 1 official at random? Question C asks, list the 5 possible samples without replacement of size 5 that can be obtained from the population of 5 officials. And then ask, what is the difference between obtaining a simple random sample of size 5 and taking a census of the 5 officials? So we'll pause for a moment and I'll allow you to get your answers. Okay, what did you say? Here's what I said. The possible samples of size 1 are G, L, S, A, and T, standing for Governor, Lieutenant Governor, Secretary of State, Attorney General, and Treasurer. Right? These are all of our samples of size 1 taken from the population of 5. Right? When we say a sample of size 1, we're just choosing one element. So when we ask what is the difference between obtaining a simple random sample of size 1 and selecting 1 official at random, well, there is no difference. A simple random sample of size 1 is selecting 1 official at random, and they mean exactly the same thing. So if I were to pick at random the Secretary of State from my group of 5 top officials, that is a simple random sample of size 1. All right, how about C? It said list the possible samples without replacement of size 5 that can be obtained from the population of 5 officials. Well, there's only one sample that we can get, right? G, L, S, A, and T, standing for each of our 5 members. And it asks, what is the difference between obtaining a simple random sample of size 5 from this population of 5 and a census of the 5 officials? Well, a census is a data that is based on the entire population. And our entire population, G, L, S, A, and T, are exactly the same thing. So in this case, once again, there is no difference between these two things. Okay, section 1.3 is coming up next.